Hi, everyone, and welcome to the live Q&A session. My name is Chen. I'm an engineering manager at Meta, and I'm going to be moderating the conversation today. First, thanks to all the speakers for their presentations. In the panel, we have the speakers from today's session: Joseph Eley, Meta; Nathan Bronson and Brandy, Rockset; Patricia McKenzie and Rohit Ahuja, Meta. And with that, we are going to start the questions. So the first question is to Joseph. What manual tests are commit authors running? Are there any required steps?
Yeah, so I can talk about that a bit. So configs, kind of like I mentioned in the presentation, are pretty difficult to test. It's not obvious to commit authors which services are consuming the configs that they're changing. And so therefore, what test a commit author should run is actually a pretty difficult thing to know. If I own a commit and are kind of working on a commit, there's some service owner somewhere else at Meta could be consuming that config, and I would just never know that. And so we've actually worked to try and build this data set that allows us to know 100% accurate which configs are consumed by which service. And so we do our best to highly recommend test plans for people, and sometimes just automatically start these tests. But it's still up to the diff authors, because we are a bottom-up culture at Meta, and we try to put a lot of responsibility on our engineers to run the right test plans, that it's not necessarily required that the tests finish or have a successful run before they land, but we do have some test plans that we try and recommend very heavily to people, and try to have a pretty good test plan before they land, but it is not necessarily required.
Thank you, Joseph. Next question is for Nathan. For the schema on read, what happens if you detect a schema in initial records, but the schema changed with later or like newer records that conflicts with earlier schema?
So the schemas that the data patterns that we're detecting in order to amortize everything are done just on a per block of data basis. So the data formats that we're actually using inside RocksDB, like the blocks that we then encode and store as key values, can always be incrementally updated with any new incoming type. It's just that if the schema varies from the pattern that we saw before, then that particular block of rows will have to get run in a heterogeneous mode instead of a homogeneous mode.
Sounds good. Thanks, Nathan. Next question for Patricia. Do you execute the privacy rules in order? How do you ensure that's efficient? Like I can imagine a really inefficient rule at the start of a policy slowing loads way down.
Yeah, so we do reorder privacy rules. We do have something called the privacy rule executor, and this makes sure that we can batch up rules for performance while preserving the accuracy. So we dispatch these batches, and all the rules that are super cheap, we try to evaluate first. These rules are ones that should have a kind of like a deterministic or a definite result. So when I was going through the presentation and talking about allow, skip, deny, we want to optimize for evaluating to an allow or a deny, not a skip for these really expensive rules. So yeah, avoiding the really expensive rules when they're not necessary.
Thank you, Patricia. Next one is for Joseph. Are config changes still a large cause of reliability issues?
Yeah, actually, in the presentation, I mentioned a couple of large incidents that were caused about a year or so ago that took out a couple of Meta's large services for quite a while, like multiple hours. And since then, we've made a lot of improvements to config safety, but still to this day within ads especially, and overall at Meta, there's still a lot of config related incidents that are caused. And we have gotten much better at preventing them. And within ads, config changes are no longer the number one cause. They're now the number two cause, right behind normal config changes and code pushes. But We're still working on kind of unifying both the normal code pushes and the config changes through that gradual rollout process. And overall, we're making some good progress, but the work we've done is just the tip of the iceberg. We have a saying here that's everything is only 1% complete. And I would say that's probably about right for config changes. There's still a lot of work to do here. So.
Thank you, Joseph. Next question for Luis. The nested indexing the size of storage can grow pretty fast. Can you talk a bit about how storage at scale? Do you use tiered storage?
So the very short answer is yes, we use tiered storage. And so when you disaggregate storage in some fashion, when you build this kind of a system with tiered storage, sort of the hotness and the coldness at each layer is going to matter a lot. It's going to affect everything, right? So that's like a significant fraction of the design of a system like this. So yes, the very short answer is yes, we use tiered storage. Nathan, do you have anything to add on that?
So we're using log structured merge trees, which means that we end up with large immutable things, which tends to work really well in a disaggregated environment. Because if you can have multiple copies of the data and you don't have to try to track mutations and consistency and that kind of stuff. And it also helps a lot with compression. So we're not just putting like one key value per index entry. We're actually like putting it into a block with like proper codings in order to get space efficiency and stuff like that. And then because we're disaggregating, we also can store fewer copies on disk than we have access to exposed to the CPUs.
Thanks, Luis and Nathan. Next question is for Rohit. You mentioned that the framework supports 30 plus backend storages. How do you deal with the different behaviors of each storage when designing APIs?
Yeah, I can talk about that. So we have an ongoing effort on the framework to make things more opaque from a storage point of view. We like to limit the amount of storage information that we expose in our APIs. Most of our APIs are generic, and we'll cover like the general operations of a storage backend, like writes, loads, transactions, and so on. But when dealing with like specific non-overlapping behaviors, we'll try to build parity at an end framework level. So for example, Tau doesn't support the concept of nullable fields, but MySQL does. And to deal with this, we'll build generic support for nullable fields at a schema and runtime API level. But in our storage adapters, we'll deal with like the storage specifics appropriately. In cases where we can't do that, we'll keep the APIs generic, but block unsupported features during verification of an end schema.
Thank you, Rohit. Next question for Joseph. Why do we run tests in land time and not review them? Not review time. Can you share some examples of issues found by this approach?
Yeah, so in an ideal world, we would actually have all of the tests run at review time. Not like normal code review, you put up a change, you get your coworkers to review it, you make sure you have a solid test plan, and then you land that change. But the way configs work here is we generate those JSONs that are read by the services, and we don't want to auto merge those. So we actually have people, anytime I rebase onto something and someone makes a change or some automation makes a change to one of those configs that I'm changing in my commit, I have to rebase on top of it. And so just because of that, there's a lot of kind of merge conflicts that we need to rebase on top of. And we want to run these in-depth review time tests that take an hour and a half or 2 hours, ideally on every one of these rebases, but there's hundreds of commits that happen every day and people are kind of trying to land everything. And so if we force people to run these hour and a half or 2 hour canaries every time they rebase, then they're just going to get stuck in this rebase land test cycle and never going to be able to actually land their changes. And so because of that, we rely on these land time changes to kind of test things as they go out the door. They're usually like 15 minutes, and it's a way to test the quality of these rebases And some of the things that we catch are just like mismerges. Maybe someone is merging on top of some other commit someone has, and they delete a line that they shouldn't have, and that line ends up being very important. It might look very innocent in the review, and when they kind of just spot check their commit, it might look good to go, but it's actually going to cause an incident. So these land time tests, that's kind of the stuff that it actually catches. But ideally, we want to test all of the changes at review time, but it's just not possible with the amount of commits that have to happen in a single day.
Mm-hmm. Thank you, Joseph. Next question is to Luis. Schemas and ingest transformation are about more than just query efficiency. What about data integrity and aggregations?
Right. So obviously, when you have schemaless ingest, the question of, well, data integrity is a very, very large topic, right? So Rockset does allow you to sort of validate your data, type check your data, things like this, so that you can ensure you have the data that you think you have. Aggregation is a much more larger topic. There's sort of two kinds of aggregations that make sense typically. So one is sort of when a new column might be a function of other columns, right? So you sort of add a synthetic column that is sort of a function of other columns. And this is the kind of input transformation that we support, and it's like fairly common. The other one that's a little more interesting is when that aggregation happens over time, right? So if you ask me every 5 seconds, like what the maximum of some stream of integers is, I can calculate that from nothing at every 5 seconds, but it's actually easier to just what we would call roll that up, right? Like I can keep that value ready to go, and those queries can then become very efficient, right? So this is another feature we support called rollups, that is its own interesting talk of this form, but not the one we gave today.
Thank you, Luis. Last question for Nathan. Could a just-in-time based execution engine also do these kinds of optimizations?
So I guess, in theory, yes, because we're LLVM can be used at runtime, and we're using Clang, which uses LLVM, so everything is equivalent. But in practice, it would actually be really hard to do. Because we're handling polymorphism, the code that you would generate would be a lot bulkier than the code that you would get in a more traditional schematized database, JIT engine, which means that your JIT is even slower. And we're also, because we're operating in the real time, we don't have very much, if your entire query only takes 30 milliseconds, you don't have very much time in order to amortize the cost of doing compilation. And then because the compilation would actually be slower because of the dynamism, I think it'd be very difficult to actually catch up.
Thank you, Nathan. So I think that's it for today's Q&A session. And thank you so much for joining. Our final set of talks in the System at Scale Summer 2022 series will be next week with a different panel of speakers. And see you there.